So I recently got back from Texas Dreamin in Austin, Texas, where I presented on zero trust integrations. I wanted to go ahead and record this presentation just to share with any others that were unable to attend the conference live. But for anyone watching or listening, it was an amazing conference. I highly recommend it. Was able to connect with a lot of folks from the community. So if you've never been before, I would definitely recommend checking it out next year when you're planning your conference schedule. My name is Scott Covert. I am a system architect at Tython, which is a Salesforce ISV with a security and access management application available on the Agent Exchange known as Permissions Assistant. And I am also the host of the Salesforce ISV podcast App Assembly Line. So for any ISVs watching or listening, please feel free to reach out. Would love to share your story. And for anyone interested or concerned about Salesforce security, please do check us out on the Agent Exchange for a free trial. The Texas Dreamin Conference was made possible, like all Dreamin events, by some very generous sponsors. Obviously, it's too late to visit their booths, but for anyone watching or listening, I would highly recommend you go and check out these different sponsors. They got some great applications, and they made a really amazing conference possible. So first, I'm going to be talking about the recent data breaches that unfortunately have been hitting a lot of Salesforce orgs over the past few years. I'm going to do a postmortem on them. I'm then going to talk about what I've been calling high trust integrations, meaning specific integrations that utilize OAuth flows that result in refresh tokens being granted to vendors. I'm going to share some of Salesforce's responses and the new guardrails that they've put in place as a result of all these data breaches. I'm going to talk about how admins and consultants can be auditing and shrinking the attack surface of their own orgs to keep themselves out of future headlines. And I'm going to be talking about zero trust integrations, specifically the JWT bearer and token exchange OAuth flows, which do not result in refresh tokens being granted to vendors. So let's talk about the three different data breach types that we've been seeing over the past few years. The first is ultimately a social engineering and vishing attack, where shiny hunters and scattered spider collaborated to call and email Salesforce admins of Fortune 500 orgs, impersonating their IT and tricking them into authorizing hackers' machines um, through the OAuth device flow supported by the data loader connected app that many admins in the Salesforce ecosystem know and trust. Um, Unfortunately, this resulted in a lot of data being exported to malicious hackers and a lot of ransoms being made. I will say one nice note is that there was a recent arrest um, related to these attacks. So slowly but surely, some justice is being delivered. And then another main type of data breach that we've seen is the supply chain attacks, where hackers gain access to an individual vendor system that results in several of their customers' Salesforce orgs being put at risk. So the most infamous case was the Salesloft incident that happened last year, where hackers gained access to a Salesloft GitHub repository, which was then used to gain access to AWS, where Salesloft had stored unencrypted refresh tokens resulting from their Drift integration that utilized the web server OAuth flow. Um, and then finally, one other data breach type that we've seen a lot of is stems from experience clouds that have poor sharing rules and overprivileged guest or community users that can result in data leaks. Now, I'm not going to get into this specific data breach itself, but essentially what a lot of admins and consultants may or may not realize is that data, just because data is not seen in the portal interface and the builder, doesn't mean that it's not still accessible via standard or API endpoints that Salesforce makes available to all their digital experience sites. So if you have not, there's a lot of information on the web out there on this. If you have not audited your Experience Cloud site in a while, now would be a good time to do so. Okay, so let's talk about the social engineering and vishing attack. Essentially, around 40 companies were targeted. Around a billion records got exported, and in each instance, really only one email or call was made per victim. So this was a very targeted attack, but a very large blast radius, unfortunately. And some would argue that the blast radius is even larger for these supply chain attacks, because basically, from a single compromised point of entry, you can expose a lot of different Salesforce orgs. And in the case of Salesloft, over 760 orgs were compromised, 1.5 billion records were exfiltrated. And that's Salesloft alone. I don't want to pick on them because unfortunately, this is played out with a number of different vendors. And it's not just Salesforce either. Uh, you know, any integration that a vendor has, if they're storing these OAuth refresh tokens in an insecure way, all those different cloud vendors' solutions would be at risk. So with a single compromised point of entry, you can, depending on how popular the integration is, a lot of different folks can be put at risk. So the supply chain attack impact is quite large. So two different types of attack, ultimately one single problem. With phishing, one phone call or email would result in a malicious user being authorized for a valid application. In that specific instance, the data loader connected app was what was targeted. With a supply chain attack, a malicious user steals valid tokens for a valid application that are just stored insecurely by a vendor. But again, the end result is the same. These legitimate authorizations are being used by malicious actors. And that's why I argue we need to move away from these single verification flows, these one-time verifications and then continuous trust, to move towards a zero trust integration ecosystem. So we need to make sure that just because our vendors are targeted or hacked, it shouldn't put our own organizations at risk. So how is this possible? In the case of the vishing attack and the supply chain attack, there were two main OAuth flows involved. Before I dive into them, I want to just quickly go over what OAuth is. It is the open authorization protocol by which users delegate access to third parties to act on their behalf for a given resource server. So obviously, in this case, we're talking about Salesforce, but really OAuth is the backbone of pretty much all integrations that you see on the web today. And certain OAuth protocols, such as the device and web server flows, result in emitting something called refresh tokens. So all the flows ultimately result in what's called an access token being granted to the vendor, and that's used to then gain access via APIs, for instance, to the initial resource server. But these access tokens oftentimes are short-lived and will eventually expire. A refresh token is what's used to generate and authorize a brand new access token when the original one has expired. Access tokens, again, are short-lived. Refresh tokens in the Salesforce ecosystem by default are indefinite and must be manually revoked in order for them to expire. Now, that's changing over time, which we're going to talk about, but that's why these refresh tokens can be so dangerous, because once they're out there, they can give carte blanche access to your org indefinitely. And the device and web server OAuth flow both issue these refresh tokens. So the OAuth protocol has been around for a long time now. 1.0 came out around 2010, and then 2.0 was released in 2012, I believe. But obviously with integrations, there's a lot of different use cases. And so there are a lot of these different flows to represent different aspects and different integration use cases you may have. Some are better suited, for instance, for server-to-server integrations where there's no user involved, and some are more hands-on. The device OAuth flow is a particular flavor of OAuth in which a secondary device authorizes a primary device. It's used oftentimes in use cases when the primary device that needs to gain access to a server has either limited or no UI for any sort of input for a user to run through the OAuth flow approval. And this is what hackers used in the infamous data loader breach. So it may sound a little complex on the surface, but I think a lot of folks watching have gone through the device OAuth flow many times using their smart TV. So when you pull up a streaming service with your smart TV, because it can be frustrating to enter in your username and password using a remote, you're instead presented with a URL, a public URL, as well as a short, unique code to enter on that web page using a second device, such as your laptop or phone. So your TV presents this code and asks you to pull out your other device and run through the authorization. And once you do so, your TV gains access to the streaming service. So this is exactly what the hackers took advantage of. They uh, used the data loader application and initiated the the device OAuth authorization on their own machine. Then they called up unsuspecting admins and tricked them into going through the OAuth approval on their machines. And that's how then the hackers were able to gain access as those admins to Salesforce. So a lot of folks get, I think, their wires crossed here, thinking that because the data loader application was open source and available on GitHub, that's what made this attack possible. But really, it's an aspect of the device OAuth flow itself. They could have used any other connected app that supports the device OAuth flow in a similar fashion. Now, the fact that data loader specifically is meant to export a lot of records, and it's already a trusted app in the ecosystem, I think that made it a good application to impersonate. But it's not the only reason why they were, just because it's on GitHub, is not the only reason why they were able to do this attack. In order to run through this attack, all they really needed to know was the consumer key of data loader and the URL of the Salesforce instance that they were trying to target. The consumer key is not meant to be kept secret. So anytime you create a connected app or an external client app in Salesforce, your OAuth configuration is assigned a consumer key and a consumer secret. The consumer key is a unique identifier for your application, but it's not meant to be kept private. In fact, if you go into the setup screens of your Salesforce instance, you could click through and look at the URL and figure out the consumer key of any of the apps that are integrated with your instance. They did, of course, I'm sure, grab it from the GitHub repository, but the fact that it's in there was not really a vulnerability on Salesforce's part. So with the device offload, the other bit of information they needed was the instance URL of their victim. This is actually, as you know, very easy to guess. Many companies just set their my domain to their company name. And there's also, it's very easy to just run a curl command to verify that your guessed URL is in fact correct. So this is the flow that hackers are able to use to gain access to so many organizations' Salesforce instances. But unfortunately, it's really more a feature than it is a bug. The device OAuth flow is set up specifically to allow a secondary device to authorize a primary one. Unfortunately, it was just used in a malicious way in this instance. Now, moving on to the web server OAuth flow. With the Salesloft and Drift data breach, what really ultimately happened was Salesloft was storing in a database in an unencrypted manner the refresh tokens that were being returned to them when their users would go through the web server OAuth flow. The web server OAuth flow is probably something a lot of folks have seen when they use something like Workbench or many other websites where they have a connect to Salesforce button. You're taken to a URL where you run through the OAuth flow. And then what happens is Salesforce returns the user to a trusted callback URL where it sends a code, which then the vendor can use to exchange for the access and refresh tokens that I mentioned before. And then it's on the vendor to store these refresh tokens in a secure manner. Unfortunately, Salesloft was not storing them securely enough because when hackers were able to gain access to their systems, they were able to find them. So again, this is why we need to move on from this high trust integration ecosystem to this zero trust integration so that when our vendors are hacked, it has no impact on us. I just want to run through a few quick demos of these specific refresh token OAuth flows now before we move on. So this here is a demo application I created to, in this specific instance, impersonate the hacker's machine. So I'm going to go through the vishing attack via the device flow. Like I mentioned, I need to know the consumer key of my connected app, which is already kind of baked into this application. And then I need to know the instance URL of my victim. So I'm going to initiate the OAuth flow on this machine, which is representing the hacker's machine. I'm going to be presented with this short URL or this short code. And then on my phone, I'm going to run through the OAuth authorization. And the primary device, my web browser here, is continuously pulling Salesforce with a secondary code that's actually not shown here, but is uniquely paired to this more user-friendly code. So the browser can continuously pulling Salesforce to check and see if it's been authorized yet by the user. And once it has been, it's going to automatically refresh. So now on my phone, I'm authorizing access, and in a few moments, that should be updated by the browser. So now we see authorization successful. The device has been authorized. So the attacker now has access. So now on my hacker's machine, I'm able to gain access as the Salesforce administrator to that org. And so you can see I'm pulling in now all the accounts from that org. I'm going to now run through the web server flow. Again, this is something probably a lot of folks have seen before, where they enter in their instance URL and then click connect to Salesforce. And we'll run through the OAuth flow. Now, I actually have already previously granted access, so the authorization was immediate. And now we can see down here, I'm able to fetch accounts from the org. But to demonstrate what happened with the Salesloft incident and these other incidents that have been occurring, the hackers gained access to a database where they saw the refresh tokens of several different organizations. And they were able to then fetch accounts from all these different Salesforce orgs. And that is the real danger of that supply chain attack, because again, the single compromised point of entry results in so many different organizations' data being put at risk. Okay, so the main anatomy of the problem is that we have these persistent secrets, the refresh tokens that are out there floating around. And we also have static permissions for these connected apps and really no governance over the setup that the vendors have created for their applications, and no control over these refresh tokens. The refresh tokens are basically skeleton keys, and unfortunately, we are just freely giving them away. Once those keys are out there, we have no idea if they're leaked, if they're being copied and handed out to other vendors. So it's not something that we should be giving out as freely as we do today. Let's talk a little bit about Salesforce's response, because to their credit, they have taken all these threats very seriously. So first off, as many of you watching already know, they've deprecated connected apps in favor of external client apps. Connected apps are still around, likely will be for a while, but you cannot create a new connected app, and you haven't been able to for some time. So what makes an external client app separate from a connected app? Well, they have really kind of split a lot of the different metadata artifacts of a connected app into multiple artifacts, which is important because it's offering now this two-layer governance. So a vendor can create some default settings for their external client app, but when it's installed to a subscriber's Salesforce org, admins ultimately are in control of changing specific OAuth policies and settings. Another big difference is that external client apps must be installed to a Salesforce organization prior to any authorization. So a previously, connected apps could be authorized by anyone with API access in a Salesforce instance. And then came along the new permission that Salesforce coined as approve uninstalled connected apps. This was granted to the system administrator profile, and folks were warned not to give this permission out lightly. That is what would allow a connected app previously unseen by Salesforce org to go through an authorization and gain access to that org through the APIs. That permission has no counterpart with external client apps. There is no ability to approve an uninstalled external client app. An external client app must be installed to the org prior to the authorization. And that's what makes the two-layer governance possible. That's what allows admins to then go through setup and customize the OAuth settings that they feel are appropriate for the vendor. Salesforce has also taken an updated approach to the OAuth device flow that I mentioned before. Again, unfortunately, it's really it's a feature and not a bug that the secondary device authorizes a primary device with the OAuth device flow. So unfortunately, there's nothing Salesforce can do to stop that per se. That said, the device flow is probably not used in too many cases within Salesforce. Yeah, one popular area that it's used is with Internet of Things, where you have hardware that literally has no UI that needs to gain access to an API. But I think many folks out there listening might not have that use case in their org. And so since it's not as popular, Salesforce has removed support for the device flow for the connected apps that they have built in-house for the data loader and for application and the SFDX CLI application. And then although they haven't shut off support for the device flow entirely, what they have done is added a lot of new banner warnings to the device OAuth flow screen. So admins or users running through the flow will see a lot of warnings that, hey, you really should not have been phoned or emailed to go through this. Make sure that you know what you're doing because you're giving out access to your org. Another huge change that Salesforce has made is they've mandated a lot of updates to their ISVs that are listed on the Agent Exchange to enable settings to make their connected apps and external client apps more secure. For anyone that is leveraging the web server flow, they're being told they must implement something called PXE, which is proof of key code exchange. Essentially, it uses another code to ensure that there's no interception of the access and refresh tokens, and that the same user that initiated the OAuth flow is the one in control of the callback URL that is ultimately exchanging the code for the access and refresh tokens. And then in regard to those refresh tokens, there are 3 new settings that Salesforce has mandated on their vendors with applications on the Agent Exchange. First is refresh token rotation. So anytime a refresh token is used to generate a new access token, that initial refresh token is invalidated. And if it's ever used again, all access tokens and refresh tokens associated with the application will be nullified, with the assumption being that basically the refresh token has been leaked and perhaps the vendor has been hacked. They're also mandating an idle timeout of 30 days. So any refresh token that's not used for a period of 30 days is immediately expired. And then finally, a very important change, IP allow listing. So now vendors are being forced to come up with an IP allow list of all the different IP addresses where where any refresh tokens granted their application could be used from. And if Salesforce receives a refresh token request from an IP outside of that list, again, the vendor is going to be assumed to have been compromised. Okay, so in addition to these big changes, what can admins and consultants be doing to audit their own orgs and shrink their own attack surface? So I would recommend anyone watching and listening to review the existing connected app authorizations for their org and revoke access for anything that's unrecognized or unused. Again, I think folks will be surprised by all the different things that do have access to their org. One common point of confusion is that just because you uninstall a managed package, a lot of folks think that means any OAuth access goes along with it, but that's not the case. OAuth tokens continue to remain valid even after the managed package has been uninstalled. And then also for any folks that have built local connected apps within their own Salesforce instance, Salesforce has made it possible for you to migrate that to an external client app. And then I recommend folks to be reaching out to their vendors that are powering integrations that their organization uses, and requesting that they also migrate their connected apps to external client apps. Okay, so let me just show you quickly what that looks like. Here is a screenshot of Tython's permissions. This is an application that has an integration analysis built in. We highlight things like any connected apps where users can self-authorize, as well as any connected apps that haven't been used in a very long time. But I want anyone listening can use a combination of Salesforce setup screens and Sockle to come up with an integration analysis of their own that I wanted to demonstrate. So here I'm going to grab this Sockle query and just copy that down for future use. But first I want to look at the connected apps OAuth usage screen from setup, which you can find just by going to the setup and typing in OAuth usage, and you'll be taken right here. You're going to see a list of all the different connected apps that have access to your org. You can even go in and see things like their user count, um, and see when they were last used, when the connection was first created, and you can revoke the OAuth access as well. So now I want to show that Sockle query that I copied before. This is a demo org, so this specific query is not going to return any results, but it's searching for any connected app that has not been used for over 3 months. So since this is a demo org, I'm going to remove that where clause. But you can see here that you can pretty easily query and find all the different OAuth tokens that have been handed out by your org using Sockle. Oh, and in fact, something I forgot to talk about when I was going over things that admins can do to protect their own org, I do want to just quickly show how a vendor could, an admin could shut down access for a vendor's external client app. I had forgotten to show that before. My apologies. So here, I'm going to show how the device flow, which we had gone through in the first instance, I'm going to begin connecting to the org using the device flow. And this is that big security warning that I talked about before. Now you can see that the process is started. I can hit connect and I could be taken to a screen where then I run through the OAuth flow. But instead of allowing, I'm going to stop here. And I'm going to show you that if you were the admin of Salesforce and for whatever reason you decided you no longer trusted the vendor, if you found their external client app, you can go in and you can even just shut off OAuth entirely. I'm going to do that. Now I'm going to run through the exact same step I did a moment ago. Excuse me. And we're going to see that now I'm immediately stopped in my tracks and told that I can't connect the device or app to the Salesforce instance. So using external client apps gives a lot more control to the admins of the subscriber orgs. I just wanted to showcase that. Okay, now I want to transition and talk a little bit about these zero trust integrations that can be built using OAuth flows that do not return refresh tokens, namely the JWT bearer flow and the token exchange flow. So with the JWT bearer flow, something called a JSON web token is created that contains information such as the instance URL of the Salesforce org that you're trying to gain access to, the user ID, or the user that the connection should run under the context of. And all this information is then cryptographically signed using a private key. And that's done to verify that the source of the connection request indeed came from a trusted vendor. Now, on the Salesforce side, a public key, the public key that corresponds with the private key that signed the JWT, that public key is used by Salesforce to validate that the JWT was indeed sent from the trusted source. And once that's done, a short-lived access token is returned, but no refresh token. In a future API call to the Salesforce instance, the request once again will be sent with a JWT that once again is signed using the private key, which will have to be validated again. So we do not have a single verification and that results in long-lived trust. We instead have zero trust, and we, on each and every request, verify that the request did indeed come from our trusted vendor. Now, a lot of folks get confused, I think, when they see this private key signature flow with JWT, and they think, well, isn't this just another isn't this just another secret that could be compromised that would once again break the trust with the vendor? I can understand the concern there, and the truth is that yes, if a vendor's private key for their certificate were exposed, it would be very bad, because then the malicious user could sign JWTs, and it would appear as a valid source to Salesforce. But AWS, Google, a lot of other cloud vendors have key management stores systems set up in place to make sure that vendors can keep their private keys secure, even from their own organization. So with key management store, essentially you can create an asymmetric key pair, public-private key pair, where the private key is never even exposed to the vendor. And instead the vendor just hits an API endpoint of AWS or Google and gets a JWT signed by the private key, but they themselves never even have access to the private key. And so that's important, because the JWT bearer flow then remains secure because that key management store keeps that private key from ever leaking outside of AWS or Google, or wherever, whatever vendor the integration is using. Another flow that does not result in refresh tokens being emitted is the token exchange flow. Now, this is a very interesting flow because it's very good for agentic AI use cases, because it's great for these multi-hop integrations where a single prompt to AI could result in 3 or 4 or more different SaaS cloud vendors' APIs being hit, Salesforce being just one of them. And so in the token exchange flow, what happens is the vendor receives a JWT that gets signed by an external identity provider, such as Okta or Auth0. And then the public key for that external identity provider is used by Salesforce to validate the JWT. And then once it's validated, the JWT is parsed for information to see, okay, who is the vendor trying to what user is the vendor trying to integrate to Salesforce as. And what's really cool is what's something called a token exchange handler on Salesforce's side can validate the JWT, try and find the matching user that it's attempting to connect to Salesforce as, and even optionally create a brand new user if one isn't found. And that's something that that you'd like to set up. And same as the JWT bearer flow, only a short-lived access token is returned to the vendor. No refresh token is assigned. Okay, so let's run through a refreshed a demo of what these no refresh token OAuth flows look like. So with the JWT flow, in order to create the JWT that gets signed by my private key, again, I need to know the instance URL. And I need to know the username that I'm attempting to sign in as. And then that's it. What happened on the back end here was a private key was used to sign this JWT. It was sent to Salesforce, which then used the public key to verify that it came from a trusted source. And once that validation was complete, it's returned the access token, which was used to pull down these accounts. And you'll note there is no refresh token assigned with the JWT. Now, the zero trust token exchange flow. In this, again, you use an external identity provider to get that initial token. So I'm going to show logging in first to Auth0. That's going to get me this initial JWT. And just to show you what that actually looks like, I'm going to pop it into JWT.io, and you can see here's the information stored in my JWT. The email associated with it is txd@tython.co. The name, which is not exactly the best name I've ever heard, but the name of the user apparently is tokenexchangedemo@tython.co. And this information is what gets sent to Salesforce and validated. And then Salesforce uses the token exchange handler to try and return an appropriate access token. I do want to show what that token exchange handler looks like. So this is something in Salesforce where you set up an Apex class to run through logic to find an appropriate user based on any criteria you deem suitable. And you can also enable the token exchange handler for specific connected apps and external client apps. I want to quickly discuss, before I actually run through the flow, what the Apex looks like for that token exchange handler. What's first used is the public key of Auth0 to verify that the token, the JWT that was sent to is valid. So that initial token is validated. And then the information of the JWT is parsed. Once it's parsed, there's Apex that looks for an appropriate user for that context, for that integration. And this is where you can customize to whatever makes sense for you. In this instance, we first try to look up a user by the email. If that can't be found, then we look them up by username. And if neither of those match an existing user, we check and see if the token exchange handler has been set up to create new users. And if so, we create a new one with the profile of standard user, and we set the username to their email address plus .token exchange. And then that is what the integration, that is the user context with which the integration will run under afterward. So now that we've gone through that, I want to go ahead and finalize going through the token exchange flow. And this is now reaching out to Salesforce with the JWT containing this information. It is then validated by Salesforce, and an access token for the appropriate user was returned. And we went ahead and hit the API to pull down the accounts for that Salesforce instance. And I want to just show, if I go over to the user tab and I were to refresh this, I should see a brand new user was created, because I did not have a user that had this email address, nor did I have one with this username. So if I go ahead and refresh this screen, I should now see that this new user was created with txd@tython.co.tokenexchange as the username. Okay, to summarize, I just wanted to talk about kind of an integration risk analysis for the 4 different OAuth flows that we talked about. The highest risk is the device code because it's subject to social engineering. A refresh token is granted. And again, it is set up to have a secondary device authorize a primary device. So it is very susceptible to social engineering attacks. And this is really a feature and not a bug that Salesforce just has to work around. Um, I assign a moderate risk to the web server flow, and that is because with the mandates that have been coming down from Salesforce, such as Pixie, refresh token rotation, idle timeout, and the IP allow list, um, the refresh token is still granted with the web server OAuth flow, which is risky, but these refresh tokens now come with a lot of limitations, which definitely makes it better than previously. The JWT bearer flow is very low risk because no refresh token is granted. This is one example of a zero trust integration. And the absolute lowest risk zero trust integration would be the token exchange flow, specifically because it requires an external identity provider to validate the vendor. So now, even if the vendor is compromised, fully, it would not have any impact because the hacker is not going to still have a valid token from Okta or Auth0 in order to run through the integration with Salesforce. Once again, for anyone listening that wasn't lucky enough to attend Texas Dreamin and visit the booths of the sponsors, definitely recommend you go reach out to them because they made an amazing event possible. If you have any additional questions, if you'd like to just chat about Salesforce security in general or Python's permissions assistant application, I would be happy to connect and chat further. Thanks so much. Cheers.